Welcome to the project demonstration of solar power grid status for Android mobile phone. So here we are going to measure the solar panel voltage as well as the temperature near the solar panels, and it will be continuously monitoring by the PIC microcontroller, and it will stream the so-called data of the voltage and temperature directly to the Android mobile phone through the HC05 Bluetooth module, and also we are going to display the same voltage and temperature values on the 16:2 LCD screen continuously. So let us see the power flow main inputs. So solar panel is provided is 12 volts input. This we are using 5 watt solar panel, that is main input from this one. So we need to connect S at this S section. Now when the sunlight is available, then the solar panel will generate the voltage. So that is the main input source to the battery through this charging circuits. So parallelly, when we connect the solar panel here, we took one more connection parallelly through this potential divider. So here we are using 10:1 potential divider to divide the voltage 10:1. So why? Because we are generating up to 12 volts. The my microcontroller can handle up to 5 volts. So to make it is less than 5 volts, we are dividing that 10:12. Means if the microcontroller gets 1 volt, so it will multiply in the formula with the 10. Why? Because 10:1 of 10 kilo ohm and 1 kilo ohm is the R1 and R2. So from A01, because the voltage sensor is connected at A1, and one more sensor LM35 is a temperature sensor, is a 3-pin IC, so which will provide the temperature value in terms of analog voltage, and that will be read by the PIC 16F72 microcontroller. And these are the main two inputs. And coming to the output modules, so buzzer and Bluetooth module and LCD are the outputs. So if is there any temperature increments, and then if the temperature is above 45 degrees centigrade, then the buzzer will be on, as well as same status will be sent to the microcontroller through the Bluetooth module about the temperature, and also we displaying the same on the LCD screen. So coming to the interfacing connections, voltage sensor A1, temperature A0, buzzer HC4 pin, and Bluetooth module at B0, B1, LCD H B22, B7. And one more main power source input is from this adapter. We are giving the 5 volts input to the microcontroller. It will take 230 volts input and 5 volts outputs. And coming to this motherboard, so we are providing 5 volts inputs, and on this there will be one capacitor. So the purpose of this capacitor is, after regulation also there may be a chance of voltage fluctuations or voltage spikes, so that will be neutralized by this capacitor. And this one is a reset switch to restart the microcontroller. And one more, this one is a crystal oscillator, which will provide the 20 megahertz clock frequency to the microcontroller. As any controller to execute the instructions which are programmed inside the microcontroller need clock pulse to execute those instructions. So based on the fabrication model of the particular controller, it was designed with a predefined oscillating frequency. So my project is PIC microcontroller, and its fabricated voltage oscillating frequency is 20 megahertz. Means it will provide the 20 mega pulses per second, so it can execute 20 mega lines per second. So directly before install, before giving the power supply to the kits, you need to install the one application of BlueTerm. So this is a BlueTerm application, and after that go to the settings, Bluetooth settings, and stay there and switch on the kits. Right. So once we switch on the kits, then there will be a welcome message on the LCD screen. Right. And now scan for devices. We'll get HC05 and pair to that. So then 1, 2, 3, 4 is a password. This is only initial setup for in every phone. After that, then Bluetooth, and scan for that. We'll get that. Once it was connected, then right. So we can see that the voltage is coming now. So toss it on your phone. So now we can see due to this low lighting on the solar panel, we get low voltage. So right, I place the torch lighting on the phone on the solar panel. Then we can see that the voltage is increasing now. Right, and coming to the temperature. So if I increase the temperature by providing the external heat source, when the temperature crosses 45 degrees centigrade, then automatically the buzzer will be on. Okay, 50. So we set the highest temperature of 50 degrees centigrade. So you can see the increased temperature here directly. So in this manner we can monitor the basic sensor values like voltage and temperature. So in the future improvements we can add current sensor and also like coolants to cool down the solar panels. So these features can be added in further implementations. Thank you.